Hello everyone, good morning. In this video, we are going to prove allied angle. Means what is the value of sine 90 plus theta in term of sine theta, cos 90 plus theta in term of cos theta. So we are going to start. Okay. So first I will write here. Our topic is trigonometry. I'm writing here trigonometry. And after all these angles are called allied angle. Theta 90 plus theta 180 plus theta, all are called allied angle. Allied angle means angles which is in the form of 0 degree or multiple of 90 degree. That is called allied angle. Okay, so we are going to prove this trigonometrical ratio of angle 90 degree plus theta, or we can say this is in 90 is in degree, or in radian we know 90 is called pi by 2 plus theta. So trigonometrical ratio of angle pi by 2 plus theta in term of theta. In term of theta. So for this, we are going to prove how we can get sine 90 plus theta or sine pi by 2 plus theta in cos theta, and cos 90 plus theta is minus sine theta c. For this, we are going to prove this. First, we are going to take a circle here. Okay, this is the circle, and first see, this is y-axis, this is x-axis. Okay, so we're writing here, this is x, this is y. Maybe this point y-axis should be in between, but okay, no problem. This is negative x, this is negative y. Okay, so see, in we have take one circle at the center where origin 0 comma 0. Now there is any point P on the circumference of the circle. Suppose this is the point P, and this point P means line segment OP. This point P making line segment OP making an angle theta with anti-clockwise direction. So we want to we know what is the position of this point P. So suppose take any point P x comma y. We have taken a point x comma y on the circumference of the circle. So for proving this, first we know we will draw one perpendicular on x-axis from P. We will draw one perpendicular on x-axis here. So we are going to prove draw one perpendicular. The name of this is M. This is M. So this is the point P is x comma y. So this OM, this is OM. OM is what? OM. This is x. This is y. So in this in triangle OPM, if we will talk about triangle, in triangle in triangle OPM, in triangle OPM. If we will talk about, and radius of this circle is what? R unit. So this we have taken a point P in the first quadrant, and the coordinate of P is x comma y. So and this line segment OP here, this line segment OP making an angle theta in anti-clockwise direction with x-axis. So in we are going to take triangle OPM. In triangle OPM, we are going to define sine theta cos theta. Okay. So see, in triangle OPM, cos theta. First we will see cos theta. So cos theta is what? X coordinate. Always cos theta x coordinate on radius. So what is the x coordinate? x coordinate position of point is p x comma y. So this is x and this is y. So this is x by r, and sine theta is y coordinate on radius. So radius for this OP is the radius. So y coordinate is nothing but y on r. And similarly, we can find tan theta p by b as tan theta cosec theta. So many ratios are there. First, we will concentrate cos theta x by r, sin theta y by r. Now see, we have given heading is 90 plus theta. So now this point P going in second quadrant, and another we can take point, this is Q. So this point is Q, this point P making angle theta with x-axis. Now this point, this revolving line, this go in second quadrant such that this O Q Y, such that this angle is theta. Okay, so making now this angle theta is in second quadrant. Okay, so see, I will erase this. Okay, so we have to find coordinate of Q. So right now we don't know what is the coordinate of Q. So from here we can make one perpendicular lines on x-axis. So from Q we are making one perpendicular line. Suppose this is N. So this is N. Okay, so see, uh, this line and this line parallel, and y-axis also. So this line parallel, this is transversal. So this angle and this angle is alternate interior angle. So this angle is always theta. So first we are going to make, this is Q, this is theta. Two triangles congruent, this triangle and this triangle congruent. So we are taking triangle QNO, QNO, and triangle PMO. PMO. In previous class, we know how can we make triangles congruent. So in triangle NQO, angle NQO is equal to theta, is equal to here also in triangle POM. Angle POM is also theta. So angle POM theta. So this is the angle. Now in triangle QNO, this QO, and in triangle POM, PO is radius. This is PO radius, and this is the side, so side. And one more, see, this is angle side, and here also this angle 90, this angle 90. So we can write angle QNO, angle QNO is equal to angle PMO, or 90 degree. So this is angle. So by angle side, angle 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 side, this triangle, both triangles are congruent. Triangle Q and O congruent to triangle PMO. Now see, both triangles are congruent, so the side opposite to theta is PM and PM is Y. So PM congruent. We can write here corresponding part of congruent triangle. So opposite theta is angle side Y, and here opposite theta angle is side ON. ON. And we know PM is how much? Y. So ON is also, ON is equal to PM is equal to Y. So ON in second quadrant for for this angle, this is Y. So we are writing here Y. So this is Y. And again, next. So this is ON is equal to PM is equal to Y. Now in TOM, this is OM. OM is equal to here QM, corresponding part, or this is OM is X, so this is X. And we know this is in second quadrant, so in second quadrant, this side, this is OX is positive and OX dash negative, so this will be negative. So in second quadrant, coordinate of Q is how much? Wherever point is there, first I will write X coordinate, then Y coordinate. So for this, here X coordinate is Y, and since in second quadrant this is negative, X is negative, so here minus Y, and this one y here X, so minus Y comma X. So we know what is the coordinate of Q, minus Y comma X. Now our heading is pi by 2 plus theta means 90 plus theta. So see this line, total angle, I am going to highlight this. For total angle, this angle is 90 degree, and this angle is theta, this angle is 90, this angle is theta. So for this angle, for this angle green color, this angle 90 plus theta. So for 90 plus theta, our line is OQ. For 90 plus theta, OQ, and OQ is the radius. So we are going to now put sine 90 plus theta and cos 90 plus theta. So writing here sine 90 plus theta, sine 90 plus theta. So we know very well sine 90 plus theta is what? 90 plus theta. Whatever angle is there, sine means what? Y coordinate. Y coordinate of Q divided by radius. So sine 90 plus theta. What is y coordinate here? For Q, y coordinate is x. So I'm writing here x by radius, x by r. Now sine 90 plus theta. Sine 90 plus theta. We know x by r. X in this quadrant P. First quadrant P. P is what? For P, cos theta was x by r. Cos theta for first quadrant, cos theta means x coordinate, ratio of x coordinate and divided by radius, so x by r. So here x by r is what? Cos theta. So sine 90 plus theta is cos theta. If I will put cos theta, cos 90 plus theta, see here cos 90 plus theta. So what cos, definition of cos 90 plus theta is nothing but ratio of x coordinate. X coordinate, since this is 90 plus theta, so x coordinate of Q, x coordinate of Q divided by R. So x coordinate of Q divided by R. So what is x coordinate? X coordinate of Q divided by R. So what is the x coordinate of Q? X coordinate of Q is nothing but here minus Y. So I'm writing here minus Y divided by R. This is cos 90 plus theta. Cos 90 plus theta minus y by r. And we know in first quadrant, sine, definition of sine theta here. Sine theta is what? Ratio of y coordinate of, I am taking first quadrant means point, for point P. For point P, y coordinate divided by radius. So y by r. For this P, this is y, and for P, this is x. So for sine theta, y by r, here y by r means sine theta. So I'm writing here minus, already here minus sine theta. So easily we can get cos 90 plus theta minus sine theta, sine 90 plus theta, cos theta. Similarly, see in this 90 plus theta or pi by 2 plus theta, in 90 plus theta or 90 minus theta, see ratio are going to changing. Sine becomes cos, cos becomes sine. All trigonometrical ratio will be changed. See. First, I will erase all things. Then better you can get understand. Okay. So sine 90 plus theta. First sine 90 plus theta. What? Cos theta. Cos 90 plus theta minus sine theta. And from this diagram we can get tan 90 plus theta also. Tan 90 plus theta. I'm writing now the formula because in exam we have to know sin 90 plus theta in 1 second. How can we get sin 90 plus theta cos theta and cos 90 plus theta minus sin theta? So tan 90 plus theta minus cot theta sec 90 plus theta minus cosec theta minus cosec theta and cosec 90 plus theta sec theta and cot 90 plus theta minus tan theta. Now we are going to use some trick. How can we remember this in 1 second? So see what is our trick here. So we know two lines are there. So this is both lines divide this plane four part. One, two, three, four. This is called first quadrant. This is called second quadrant. This is called third quadrant. And this one is called fourth quadrant. So see, in first quadrant, all trigonometrical ratio positive. In first quadrant validity what? In first quadrant, validity of angle is 0 to 90 degree. So in first quadrant, validity of angle is what? 0 to 90 degree, or we can say 0 to pi by 2. In second quadrant, because total angle is 180, and we are going to second jump from here. So 90 to 180. 90 to 180. For third quadrant, 180 from here to here, 180 to 270, 180 to 270, and fourth quadrant, 270 to 360. How 270 to 360? Because this is 90, this is 180, this is 270, and total angle is 360. So in fourth quadrant, validity of angle is 270 to 360. Okay. Now in first quadrant, we have to know about all trigonometrical ratio positive. All trigonometrical ratio positive. In first quadrant, we can use all trigonometrical ratio positive. We can write here. First, I will erase this. Okay. Now, in first quadrant, again we are drawing this. In first quadrant, all trigonometrical ratio positive. All trigonometrical ratio positive. All means sine, cos, tan, cosec, sec, cot. All trigonometrical ratio positive. We should know about in second quadrant. In second quadrant, sine and its reciprocal, sine, cosec, positive and rest negative. We should remember this, rest negative. In rest, tan, cot, sec, cosec. So sine, cosec positive, rest negative. In third quadrant, we have to know about that tan and cot. This positive, tan and cot positive, and rest negative. Rest means sine, cosec, sec, cos, all rest negative. And in fourth quadrant, cos, sec, positive, and rest negative. And rest negative. And one more thing, whenever angle 90 is there and one more angle 270, we will prove it. But right now we have to remember this in 90 degree and 270 degree. Trigonometrical ratio will be changed. So I'm writing here in note. What in 90 means pi by 2 and 270, 3 pi by 2, 3 pi by 2. Pi is radian, so pi is 180, 180 by 290, 93 that 270. In 90-degree and 270-degree trigonometrical ratio will be changed. See, in 90, sine change into cos, in 90, cos change into sine, in 90, tan change into cot. That's why I'm writing here in 90 and 270 trigonometrical ratio will be change. Will be change. Will be change means sine becomes cos and cos becomes sine. Tan becomes cot and cot becomes tan. And sec becomes cosec and cosec becomes sec. So we have to remember this in 90-degree and wherever 90 and 270 plus minus there, and either 90 plus or 90 minus, either 270 plus or 270 minus, trigonometrical ratio will be changed. Sine becomes cos, cos becomes sine, tan becomes cot, cot becomes tan, sec becomes cosec, cosec becomes sec. Now by trick we will remember this. How can we remember? In 1 second. So first I will erase this once again, and I will writing and I will remember this in trick. This is very easy for the student. See, you don't use always proof. So in JEE Mains exam or 11th, 12th exam, so no need to prove all things in subjective way. So directly, how can remember this? To see, wherever suppose somebody say tan 90 plus theta, or tan 90 minus theta, or tan 270 minus theta, or tan 270 plus theta. So see, first it is 90. So in 90, what I told earlier, in 90 ratio will be changed. Tan convert into cot. Okay. Cot. Whatever angle is there, 90 plus theta. So theta. Suppose I'm going to highlight this. Suppose here tan 90 plus 56. We can write direct cot 56. If tan 90 plus ABC, so I will write cot ABC. Whatever angle is there, I will write angle here. Now see, so first tan 90 plus theta cot theta. Now we will see 90 plus theta in which quadrant. So 90 plus theta, this is 90, and 90 plus means moving to this quadrant, second quadrant. So we know in second quadrant, sine and cosec positive, rest negative. So we have to see here in second quadrant, tan negative. So tan 90 plus theta minus cot theta. And tan 90 plus theta. Here also 90 plus minus 90 minus. So tan becomes cot theta. And see, 90 minus theta. So this is 90 minus remains first quadrant. In first quadrant, all positive. We have to see this. So in tan positive. So positive. Don't see here 90 plus theta, second quadrant, second quadrant, don't see cot. We have to always see about this tan 90 plus theta cot theta, and 90 plus second quadrant tan negative. Also 90 minus theta first quadrant, in first quadrant tan positive, so positive. Now 270. So see 270, I have told earlier in 90 plus minus theta and 270 plus minus theta ratio will be changed. So tan becomes here also cot theta, and see 270 minus theta which quadrant? So this is 270. This is 270, and 270 minus theta remains here third quadrant, and third quadrant what I told tan positive. So tan 90 tan 270 minus theta cot theta, but tan 270 again 270 plus theta, so tan becomes cot, and 270 plus theta where? Fourth quadrant. Here 270, add something, fourth quadrant, tan negative. So tan 270 plus theta minus cot theta. If somebody asks what is the value of cos 225 degree. So I'm giving some example, cos 225 degree. So see, cos 225 degree. How can we find? We don't know cos 225. Till 10th, we know about 0 to 90, but this is 225. So many methods are there. So first, we can make 225 in the close of 270. How can we write 225 in terms of 270 plus theta or 270 minus theta? So see here, cos, we will write 270 minus, we don't know, so just subtract 270, just subtract 225 from 270. So 270, 225, 5 4, this one, 45. We can write easily. See, 270 minus 45 is 225. 225 plus 5, 230, 40, 270. So see, cos 225 is cos 270 minus 45. So cos 270 minus theta. So cos 2, this is 270. What I told in 90 or 270 ratio will be changed. So cos 270 minus something is sine something. Something means cos 270 minus theta, sine theta. So sine 45, now we will see 270 minus 45. Which quadrant? This is 270. Subtract third quadrant. In third quadrant, cos negative, so minus. So here minus 1 by root 2. We know sine 45, 1 by root 2. Very easy it is. I am giving some more example to better understand. So first I will erase this. If somebody asks, what is the value of sine 135? So again, so many methods are there. So sine 135, sine 135 is the close of 90 and 180. So 180, I will give the example later. First, sine 135 is written 90 plus 45. See, 90 plus 45 is 135. Now see again, this is 90 plus something. So whenever 90 is coming or 270 is coming, sine becomes cos. So cos 45, and first we will see in the second quadrant 90 plus something. 90 plus something goes into second quadrant. And second quadrant, what I told, sine and cosec positive. Sine and cosec positive. So here we will see this. We will not see cos, we will see sine. 90 plus 45, sine, second quadrant, and second quadrant sine positive, so positive. Cos 45 is 1 by root 2. If I will say cos 135, same method, close about 90. So 90 plus 45. Now again 90 plus something. So cos becomes sine, sine 45. And 90 plus 45 second quadrant. In second quadrant cos negative. So I will put here negative. So minus 1 by root 2. So minus sine 45 minus 1 by root 2. So it is very important and very easy. So many angles we can give the definition. Again, if I will say sine C 2, if I will put sine 2 to 225. Okay, I have given an example of sine 225. Later I will give some example. So I think it is clear for everyone. So see, now first I will erase this. So sine 90 plus theta, cos theta, wherever 90 and 270 is coming plus minus, so ratio will be changed. Now I am writing here trigonometrical ratio. Trigonometrical ratio, trigonometrical ratio of angle 180 plus minus theta in term of theta, in term of theta. So see, sine, I'm writing here 180 minus theta. So what I will do, sine 180 plus theta. So we know sine 180, so many methods are there. So by trick, we are going to prove sine 180 minus theta. So 180 can be written 90 plus 90 minus theta. So students, be careful. Here sine 90. After 90, this is our angle. Suppose 90 minus theta is A. So this will become sine 90 plus A. So here also 90 plus A. Wherever 90 is there, ratio change. So sine becomes cos, and after 90 is it is a cos A. And see, we will see 90 plus something second quadrant, and second quadrant sine positive to cos A. But we have given example. Heading is 180 plus theta minus theta in term of theta. This is not theta. So cos, what is the value of A? A is nothing but 90 minus theta. So again, 90 is coming, to cos becomes sine, and theta, 90 minus theta is the second, first quadrant, first cos positive, so positive. So final is sine 180, this one, 180 minus theta remain sine theta. So trigonometrical ratio will be changed only 90 and 270. Else it remains same. This is not 90, this is not 270, so sine becomes sine. So sine 180 minus theta, sine theta, and we will see 180 minus theta. Which quadrant? So 180 is total 180 minus something, second quadrant sine positive, so it will remain positive. Now if I will talk about cos 180 minus theta, so cos, we are not going to give the this subjective definition. Directly we are going to write cos 180 minus theta. So cos 180. This is not 90. This is not 270. So cos remains same. Cos theta. And first we have to see this 180 minus theta, second quadrant, and second quadrant cos negative. So negative. So cos 180 minus theta minus cos theta. Now tan 180 minus theta. This is not 90. We are highlight one more time. So this is a 180, not 90, not 270. So sine remains sine. This is 180, not 90, not 270. So cos remains cos. Only we have to see which quadrant it lies. 180 minus theta, 180 minus theta, second quadrant cos negative. So cos negative. First, second quadrant sine positive. So sine positive. Okay. So next one is tan 180. Tan, this is not 90, not 270. Tan remains same. Tan theta. And one more time, 180 minus theta, second quadrant, second, tan positive. So positive tan theta. And one more, cosec 180 minus theta, sec 180 plus theta. Very easy it is. Remains same. Cosec theta, and sec theta. But it is not correct. First of all, we have to see 180 minus theta, second quadrant, second in cosec positive. So it is positive cosec theta as it is. So cosec 180 minus theta, cosec theta, and sec 180. Third, acha, we have written here 180 plus theta. Okay, no problem. So 180 plus theta, this is not 90, not 270. So sec remains sec, and this one is 180. This is 180 plus something, third quadrant tan and cot positive, but this is sec negative, so negative. And also sec 180 minus theta, what I do, sec theta, and second quadrant sec negative, so negative. So sec 180 plus theta also minus sec theta, and sec 180 minus theta also minus sec theta. So, and cot also same formula, cot, if I will talk about cot 180 minus theta, I will write here minus cot theta. How? Because this is the second quadrant, cot negative, so negative in 180, cot will remain same, cot theta. So it is very important. This is a 180 minus theta. Similarly, we can do cos 180, trigonometrical ratio of angle 180. This was 180 minus theta. Now we will do 180 plus theta. So here I'm doing this 180. So different color I'm using, red color. Okay. So green is for, so if I will take plus, plus sine 180 plus theta. So this will remain also sine theta, but this will remain sine theta. And this is the 180 plus something, third quadrant, in third, tan and cot positive, rest negative. So sine is negative. So minus sine theta. So sine 180 minus theta, sine theta, but sine 180 plus theta, we will write minus sine theta. Now for cos, if I will take plus, so cos 180 plus theta. So cos 180 plus theta, cos theta, and this is third quadrant. In third quadrant, cos negative, so negative. But in fourth tan, if I will talk about tan, so if I will take plus, So this is note 90, note 270, tan remain tan, and tan 180 plus tan 1, it was tan 180 minus theta, it was minus tan theta. Tan 180 minus theta, second quadrant, second tan negative. So tan 180 minus theta also minus tan theta. And for third quadrant, 180 plus theta, third quadrant, in third quadrant, this tan is positive. So tan theta. And similarly, if I will talk about cot 180 plus theta. This is not 90, not 270. So cot remains same, cot theta. And it is third quadrant cot positive, so positive. Cosec next, cosec 180 plus theta. So this is not 90, not 270, remains same, cosec theta. But this is third quadrant, third cosec negative. So I will write here negative minus cosec theta. So it is very important. Okay, thank you.